Worksheet 4.1, question 7. So here we have a ship sailing at a bearing of 55 degrees or 55t. So we're going to draw our compass bearings in to start with. We have our north, our 0, our east 90 degrees, south 180 degrees, and west 270 degrees, back to 360 degrees here. So here we're sailing at a bearing of 55 degrees here. So this is our angle here, will be 55 degrees. And that's starting at our point X. We observe two other ships in a line due north. So we're going to see our boat A and B. After travelling 7 kilometres, so this is our point Y in 7 kilometres, one ship bears 290 t. So here we draw our angles in 0, 90, 180, 270, 290. So this angle all the way around here is 290 degrees. And here our angle to ship B is 320 degrees. So we draw this one in around to here, 320 degrees. So now if we look at this, we have a large triangle XYB and two smaller triangles XYA and BAY there. So we've got here, and we have one length here on this triangle. Here it's on our large triangle XYB, and it's also on our smaller triangle XYA here. So we're going to find out, we have this angle here, we're going to find this angle here. So all the way around to here is 290 degrees. We know, well, around to this point here is 180. Using our alternate angles here, this will be 55 degrees to match this one here. So our angle here will be 290 minus 180 minus 55 degrees. And that will give us an angle of 55 degrees here. So now we can work out this angle here will be 180 degrees minus 55 degrees is equal to 70 degrees here. So if we separate this this triangle out, just to make it a little bit clearer, we've got X and Y and A. We have 7 kilometres, 55 degrees, and 70 degrees here. So we have this triangle here. If we look at it, we want to find this distance here, AB. So we'll call this AB to make it a bit easier. And what we can do, we can find with this angle here, we could find this length AX. But that's not going to help us too much here to find our AB. So we're going to go on from that. We're going to find this length here, our AY. If we have that length here in our smaller triangle here, we'll be able to find our length AB. And if we look at our big triangle, XYB, our total length here is XB or BX there. So what we're going to do is find this length AY here. We'll find our AX first. So here we have 7 on our opposite angle sine of 70 degrees is equal to our length AX divided by sine 55 degrees. We rearrange and we have AX is equal to 7 sine 55 degrees divided by sine of 70 degrees. And we look at our formula at the top, we've got this part and this part, so that's looking nice and positive, isn't it? Here. So now if we look at our next triangle, we're going to look at our triangle BXY. What happened? Here. So we want our triangle BXY here. We have 55 degrees here. So now for this part here, we've got to find our angle size there. So we know that this part is 55 degrees. And then here, this part on this side is 320 degrees minus 290 degrees here is 30 degrees. So our whole angle size here will be 55 degrees plus 30 degrees is equal to 85 degrees here. So here, this angle here will be 180 minus 85 minus 55 is equal to 40 degrees here. And we know on this large triangle this is 7 kilometres here. So we can find our length BX here. So here we have 7 divided by sine of 40 degrees here is equal to our length bx divided by sine of 85 degrees. We rearrange and we're getting bx is equal to 7 sine 85 degrees divided by sine of 40 degrees here. And if we look here, we're wanting to find our length AB. So here, if we have our total length, BX is our total length here, and we minus our length AX here, that will give us our length AB. So here, our AB length here is BX, 7 sine of 85 degrees divided by sine of 40 degrees, minus here our AX is 7 sine 55 degrees divided by sine 70 degrees, and if we take our 7 outside of our equation here, sine 85 degrees divided by sine 40 degrees minus sine 55 degrees is equal to sine 70 degrees is equal to our formula here shown.